So now that we've talked about what the ManagedBlocker interface and mechanism does, let's show how you can apply it. And we'll demonstrate this through an example. You can find the example in my EX33 project, in my Java 8 folder, in my live lessons GitHub repository, which has a wealth of other fun and cool things related to the topics we cover in class. So this example is going to demonstrate a bunch of techniques that are shown in the Java documentation, the Java doc documentation. So if you read the Java documentation for ManagedBlocker, it'll show these examples, but it just shows them as little snippets that don't actually run. So I stuck them into a program so you can actually try them out. So the first thing we're going to look at is the so-called ManagedLocker. And the ManagedLocker implements ManagedBlocker, and it handles a blocking synchronizer. So it implements the ManagedBlocker interface, and it defines a field that's a ReentrantLock. ReentrantLock is a very common synchronizer that's used in Java. And what ReentrantLock does is it can be used to provide mutual exclusion to ensure that only one thread at a time gets into a so-called critical section. So the good analogy of this is the restroom in an airplane where one person is supposed to be in there at a time, and it's got basically a state that's either occupied or vacant. And when it's occupied, you have to queue up and wait. And when someone comes out, it goes to vacant, and then the next person can come in and shut the door, and it becomes occupied again. So that's kind of what a ReentrantLock is like, metaphorically. So you can see that the constructor stashes a ReentrantLock away in a field. And then the isReleasable hook method, remember, this is the one that's going to be called by the fork join engine to try to see if it gets lucky and doesn't have to block. And so what it'll do here is it'll try to acquire the lock without blocking. So there's a try lock method on a ReentrantLock, which, if you're lucky, will get the lock without having to block, like if there's nobody else who owns the lock at this point. So if we happen to get lucky, then we set the hasLock flag to true, and we return true, and we're done. If we're not lucky, then the framework, the fork join pool framework, has to call the block method. And you can see if we don't have the lock, it's going to call the lock method that actually blocks. So this will wait until no other thread owns the lock, the ReentrantLock, and then we can acquire it atomically and return true. So that's one way of being able to use ManagedBlocker in order to be able to handle things that may block due to locks. Not the only way to block, but that's one way to block. Here's an example of how we do this. We're going to make ourselves a new ManagedLocker that encapsulates a ReentrantLock, which is defined elsewhere in that example. We then acquire the lock, so the lock is held. We go ahead and use the common fork join pool to run this code. This code is going to go ahead and call the ManagedBlock mechanism on the fork join pool. Remember, it's a static method, so we don't need to call it on an instance of fork join pool. We can just call it. And we pass in the locker object, so that'll go run in the background. And now remember, the lock is locked. So what's going to happen here is this is going to basically have to wait. Then the main thread, the thread that started this thing in the background, sleeps for a second, and then it calls on lock. And so what will happen here, if you run the code, is it'll wait a little bit, and then you'll get the acquired the lock call after this unlocks the lock. And then in that case, this computation here will be able to do its thing because it will have been able to acquire the lock. Let's take a look at another example. This is called QueueTaker. So QueueTaker also implements ManagedBlocker, and this is designed to handle a blocking queue. We'll talk about what a blocking queue is in just a second when I show you an example. A blocking queue in Java is a concurrency synchronizer that uses message passing to allow producer and consumer threads, one or more producers, one or more consumers, to be able to coordinate through the blocking queue. This is typically referred to as the bounded buffer problem in concurrency theory and concurrency concepts. So what we do here is we are going to pass in a blocking queue, and there's a couple different implementations that come out of the box, like array blocking queue and linked blocking queue and so on. We stash the blocking queue in a field, and then we make the isReleasable method try to acquire an item from the queue without blocking. So the poll method is used to check to see if there's an item in the queue. If there is an item in the queue, it'll return it without blocking. If there's no item in the queue, it returns null, meaning that there was nothing in the queue. So and that's what is used for isReleasable. If we are not lucky and there is nothing in the queue, then we're going to have to block. And you can see what we're going to do here is called the take method. And the take method is a method that a consumer calls when it wants to wait to acquire an item from a queue. Remember we talked before about message passing in concurrent programs. This would be an example of message passing. So in this case, we're going to block until there's an item in the queue, and then we return true. And we also have a method called getItem, which returns the item after the pool managed block method completes, so we can actually get what came back from the queue. So let's take a look at how we might program something to do this. This, again, of course, is in that example program EX33. And you can see that the first thing we do is we make ourselves a QueueTaker that's parameterized with a string, and we're going to give it some BlockingQueue, which is defined elsewhere in the program. And then, much like we did before, we're going to go ahead and put something in the background, which is going to go ahead and run the ManagedBlock method on the fork join pool, passing in the taker, which is the BlockingTaker. And then we're going to go ahead and sleep for a second, and we're going to put an element into the queue. So we're going to say put hello. And until that point, this call here is not going to, rather, this won't get called. This call here will block until an item is available. And then when we call the getItem method here afterwards, this call will not actually block. The call above it will block. OK, so that's basically how you can use a ManagedBlocker with some kind of buffered queue or bounded queue. There are other ways to do this as well, things for I/O operations, and that's actually what you'll be using it for when you implement or when you have implemented the programming assignments for the course. You'll be using the ManagedBlock mechanism deep in the bowels of what you're doing, and we'll talk about that. You've already seen some of that in Programming Assignment 1, and we'll do it again in Programming Assignment number 2. So that's the end of applying the Java Fork Join Framework's ManagedBlocker interface to a couple of examples that come out of the underlying Java documentation for ManagedBlocker.